Okay, welcome. Today we're going to look at finding the end behaviors of a rational function. So our objective today is students will determine the end behaviors of a rational function by finding the horizontal asymptote. We have three cases to look at, and we're going to tie this into yesterday's notes. So go ahead and pull those out and we'll get going. Remember to pause the video at any time you're falling behind, or rewind the video if you didn't quite understand something. Sometimes it takes 2 or 3 times before you can make the connection. Okay, so let's go ahead and begin. And we're going to look at this in general terms. So what it means, we're going to use our imagination a little bit. All right, so what I have here is a graph and part of a rational expression, rational function. We have f of x is equal to 2x plus, and we don't really care what's going on behind it. It could be just 2x, or we could have other terms, over 4x squared, followed by whatever other terms if they exist. And the reason we're looking at it like this is because we only care about the first terms. Our first terms determine our horizontal asymptote and therefore behavior. So we're going to do a lot of pretending. So let's pretend I have this graph, and over here I have this asymptote. It looks something like this. Okay, now this is our vertical asymptote, the one we can't touch. And we're going to find the horizontal, the one we can touch, the one that guides our end behaviors. So let's look at a few key points. Okay, what we want to look at are our exponents on our variables of our leading term. We can see this has an exponent of 1, and this has an exponent of 2. Since 1 is less than 2, this implies we have a horizontal asymptote at y is equal to 0. That's the rule. An easy way to remember the rule is simply do the division. X divided by x squared. So if we think of it like that, x squared goes into x 0 times. So you can memorize the rules, and they're in our text, and we can look at those, or you can simply go by division. X squared, x divided by x squared goes in there 0 times. That implies our asymptote is at y is equal to 0. Okay, so we'll go over here and draw that. Here's our y is equal to 0 line. Remember, this is our horizontal, the one we can touch. So it's going to come something like this. So our graph of a particular function, and we're going to make some points up. Let's pretend it had a y-intercept of here, and we'll have no x-intercept. This would tell me that our graph would start over here because this is the end behavior. It's down here. And it's going to come up and go through this point. And as I keep going, I know I can't touch this, so it's just going to shoot way up in the air like that. Okay, the other side of the graph, we would have to plug in some points, and let's just say we did, and we found we had a point here. We could say this is our end behavior, because again, horizontal asymptote guides the end behavior. And it's going to come through this point and shoot down. And that could be a graph. Now remember what we're trying to do here. We're trying to figure out the horizontal asymptote and how it guides the end behaviors. If you have the end behaviors as x goes to negative infinity and x goes to positive infinity, you can use other points that you previously found, and the vertical asymptote, the one you can't touch, to help you sketch what this graph might look like. So again, remember, our goal is to be able to understand how to find the asymptotes to get the end behaviors, and then we can work on putting it all together. Okay, let's look at another example. So there's one case, and that case is where the power on the numerator is less of that power on the denominator, and that's y is 0. And let's go ahead and pick a new problem. Woo, lost it there. Here we go, we're back. Okay, so let's change our problem up and look at the next case. Let's just say they were identical. Now we both have 2. We know 2 is equal to 2. So what happens if they're the same? Well, let's go back to the dividing case. If I were to divide these, they would cancel out. So when your powers are the same, or they cancel out if you divide them, you're simply left with the coefficients out in front, which would be 1 over 2. So what this implies is our horizontal asymptote is up at 1/2. So let's go to 1/2. So we'll call this 1. So this would be 1/2. So our end behaviors, here's what we know on the graph. Now I don't know what side it's coming from, but I know the end behaviors look like this. And again, if we want to imagine and make some points up and pretend we have let's put our vertical asymptote here. And remember, again, we're imagining, doesn't have anything to do with this problem as it sits, but let's just pretend the problem we had a vertical asymptote here, and maybe a 0 here, and maybe an x-intercept here. From this information, we can sketch the graph. We can say, okay, I can't touch this line, so the graph comes down, goes through this point, and again, there's our end behavior, what we're looking for. This point here, again, I know it has to come through this point, and I know it can't touch that, so it's going to come down, and again, there's our end behavior. Okay, so what we've seen so far is if the numerator power is less than that of the denominator, it's at 0. Think of dividing. The top can't go into the denominator can't go into the numerator, it goes in there 0 times, it's at y is 0. If they're the same, then it's the coefficients. You can see how they can cancel out. So let's look at our final case. And let's look at that. So let's clean up the screen again. So our new case looks something like this. Okay, we have 2x squared over 4x. Remember, we don't care what's following, it's just this piece here. And we're going to use the division thing again. So in this case, 2 is greater than 1. So our numerator this time is greater than the denominator. So the first time it was less than, the second time it was equal to, now it's greater. What happens here? Well, let's do the division thing again. So 2x squared divided by 4x, and this will help us with our rule. We can see that 2 over 4 is simply 1/2, and we can see x goes into x squared one time, leaving an x on top. So this implies we have the coefficients of 1/2, just like the previous problem, but now we have an x. Okay, so we need to interpret this a little bit. This is no longer a slant or a horizontal asymptote. It's called a slant asymptote. It still guides our end behaviors, but it's not horizontal anymore. And what gives it away is the x. Okay, this is not a horizontal line, this is a linear equation. So let's go put in some numbers and see what this looks like. So again, we're going to make up a vertical asymptote. I'm just going to place it anywhere. To make it easy, let's go through here. And let's pretend I go through x-intercept here and y-intercept here. So what's this going to look like? Well, we know that if I graph this line, y is equal to, let's write it here, y is equal to 1/2 x. This is the asymptote that will guide our end behaviors. We can see we have a y-intercept of 0 and a slope of 1/2, so 1 up, 2 over, 1 up, 2 over, 1 up, 2 over, 1 down, 2 over, 1 down. So all I'm doing is graphing this line. So in this case, our asymptote is slanted. Okay, so the vertical is the one we can't touch, and the slant is the one we can touch, but guides our end behaviors. So on this side, or the right side, the graph's going to come really close to the vertical. It's going to come down. Now it may touch it, it may go through it, but what I know is it guides the end behavior. The end behavior is shooting up this way. So that's a good representation. Same thing on the other side. Can't touch the vertical, so I come real close. I know it's going to go through this point. I know it's going to go through this point, the zeros, and the x and the y-intercept, and it's going to shoot down this direction. because remember, it guides the end behaviors. Okay, so this was just a short video on how to find the horizontal asymptotes, or in this case, the slant asymptote. There were three cases. Case number one, where the power on the numerator was less than that of the denominator. Case number two, where they were the same, and case number three, where it was larger than that of the denominator, which made it a slant asymptote. So go ahead and walk away. If you're not quite understanding how we did the graph, make sure you understand how to find the asymptotes, and we'll work on the rest in class. Okay, if you have any questions, go ahead and jot them down, and we'll handle them in class.